Good afternoon, everyone. Welcome to Bridge to India's webinar on PV module landscape. This is Sangeeta Suresh from Bridge to India. Thank you all for joining us today. I would like to introduce you to our panelists for the day. Here to talk about the latest developments in the module technology are Chris Liu, Technical Head LONGi, and Sai Charan, Technical Director, Jinko Solar. Also on the panel today are Mr. Ivan Saha, the CTO of Renew, and Dr. Nikhil Agrawal, AGM Technical from Mahindra Susten, here to share their views as developers and EPC contractors, respectively. I would like to mention a special word of thanks to our sponsor, LONGi, whose support enables us to bring quality content for our audience. Now on to the agenda for the day. We will begin with a brief introduction by Mr. Vinay Rustagi, Managing Director, Bridge to India, on the current PV module landscape, followed by individual remarks by panelists, and we will then have a panel discussion followed by Q&A. Our participants are requested to send your questions at any time through the text box located at the bottom right corner of your webinar. Finally, during the webinar, we will have a poll that is conducted and a few feedback questions as well at the end of the webinar. We request you to please provide your responses, as this will help us to create future webinar content better. Now over to Vinay for introductory remarks.
Thank you, Sangeeta, and thank you again to all the panelists for joining us, as well as to all the attendees on the webinar. So I'll just quickly take about 5 minutes, just giving an overview of the module technology landscape for the Indian market. I think it's really very, very exciting. There is a step change in the technology landscape as we speak. And it seems that the pace of technology changes is actually going to accelerate going forward. And I would broadly classify 3 kinds of changes in the market. One, there is a change in the module technology, the cell technology itself, as the chart on the left shows. Multicrystalline almost sounds like an obsolete word now. Monoperc and the various mono technologies have become mainstream. The second change that we see in the market is that the wafer cells and the modules are getting bigger and bigger. And it's no longer a question of is bigger better, but the question has now suddenly become how much big is better, taking into account various installation, execution, and logistical issues. And what the increase in size is doing is reducing the BOS costs, the cabling costs. It is cutting down on installation times. And of course, together with cell technology, it is making the module technology more efficient with higher power output for every watt peak. Sorry, Ankita, please go back. And the third change that we see in the market is that the way the cells and the modules are being put together is changing very drastically. Of particular note, I think, is the way bifacial modules are rapidly gaining acceptance in the market. I think this chart made with PV InfoLink data, if anything, seems to be more conservative. What we see in the market today is that all the larger developers are actually mainstreaming use of bifacial modules even today. And we expect that many of the larger projects in 2020 and 2021 in India will already be using bifacial modules. Ankita, let's move on. The other change that we see in the market alongside the changes in technology is the rapid pace at which the capacity in the industry is increasing. And what you see in this chart, the cell capacity is broken by wafer sizes, is that all the new technology, all the new capacity, is coming in at the larger wafer sizes towards 182 and 210 mm. There are many implications with these changes. One, the larger suppliers, because of their ability to invest in new facilities, are gaining market share. The industry is getting consolidated. The tier 1, tier 2, and tier 3 suppliers are no longer able to compete, being unable to invest at the same pace. And then the question is, if the capacity is rising so rapidly, what is the implication on price? Now, this chart shows a cell capacity of more than 350 gigawatts in 2021. In comparison, today or this year rather, the total and global deployments are expected at about 150 gigawatts. So, if there is so much global overcapacity, then will there be a downturn in prices? Ankita, let's move the slides.
Sorry, Vinay, please hold on. There's a lag.
Okay. So while the slide is being updated, what I wanted to mention was that this change is not stopping anytime soon. We have various new technologies like heterojunction, TOPCon, and IPC, which are expected to become mainstream over the next 3 to 4 or 5 years. And the sum and substance of all these technology changes is that you get higher energy yield, the cost of production of power goes down, the reduction in land requirement, there's a reduction in land requirement as well as BOS costs, and the life of the modules is also increasing. Uh, in total, the effect is that LCOE of solar production is going down, which I'm sure is music to everybody's ears, particularly in India. But I should warn that it's not just module technologies, it is also a lot of financial changes, particularly the reduction in cost of capital, which is driving LCOE in the latest bids. Uh, there are equally significant implications of these changes on the manufacturing prospects in India. What is the potential for Make in India, etc. But we are not going to be discussing that today. The focus of the webinar is going to be mainly about deployment of new technologies and the reduction in cost as a result of that. Finally, what we see on this slide is that the prices of the modules have been a little bit more volatile in the last 1 year. This volatility is probably the highest we've ever seen in the market over the last 6 to 7 years. And there are a number of reasons for this. In particular, I would say as the modules have become bigger, the ability of the larger glass suppliers and even the polysilicon makers, as far as we can make out, is getting constrained. And that is putting a bit of a pressure on the supply lines. The demand supply matches and mismatches are getting localized, producing these sharp increases and decreases in prices. And finally, it's not all good news, I guess. For the developers, it was all a very simple world when it comes to deploying solar technologies. But now, increasingly, they face many more very intricate and tricky decisions. Which technology to use? Will the modules be available in India? What is the certification status? To use trackers or not without trackers? Are these modules bankable in India, so on and so forth. The other change which is happening in the market is because of this rapid changes in technology, the time from launch of a new technology to usage and deployment in the field is actually coming down. And that in itself is giving to concerns, rise to concerns like, are these new technologies reliable? Have they been tested enough? Are they bankable, etc. Not. So here to discuss all these issues with us. Fortunately, we have a very capable panel. We've got two of the world's biggest cell and module suppliers, Chris and Sai from Jinko and LONGi, and then Nikhil and Ivan from Mahindra and Renew. What I will do is I will come to each of the panelists one by one. I'll give them a chance to speak for about 3 to 5 minutes, and then we will go to a more interactive discussion. So, Chris, if it is all right with you, we'll start with you. LONGi has been at the forefront of launching many of these technology changes. I want you to give a little bit of color, the slides that we presented in terms of the various changes in cell technologies, modules, etc. give us more color on what is happening, what is driving these technology changes, is that what kind of pace of reduction in LCOE can we expect as a result of that? Over to you, Chris.
Hello. Hi, Vijay. This is Chris from LONGi Solar. And firstly, I want to thank the organizer to give us this great opportunity to talk to you about the technology in the coming years. So firstly, I think the technology. Let's start from the technology. So as we all know, that LONGi is a technology-driven company. So in the last 3 years, all the great technology innovation happened in the solar market. I think it's led from by LONGi. So we insist our mono wafer, mono PERC. Then we have a bifacial mono PERC technology. I think this is already changed the whole market from poly to mono PERC and to bifacial PERC. So why we can have this technology change? So firstly, as I think we are the biggest wafer players in the world, so we firstly introduced the diamond saw wire cutting for the wafers, so which can reduce the curve loss, and you can get more wafers from one ingot. So this helps us to reduce the wafer cost quite a lot, to be honest. Then we integrate the cell technology on PERC. PERC is the kind of knowledge, I think this is all, the technology was already there 5 or even 10 years ago. But with our low cost mono wafer, we made it to the commercialize this product finally, and then to the market. So I think 2 years ago, we did quite a lot of marketing work in the whole world. And now we can see that the whole market now is, I think, is using mono PERC already. And to India, I think India, to be honest, it's a little late than other countries, but we can already see that last year, I think only from LONGi, we shipped more than 1.4 gigawatts, all mono PERC to Indian market. I think the market is already changed. And I'm also very happy to see that in your prediction that the bifacial also is happening in India. Also, I'm very glad, very happy to see that. Because what I want to share is, I think outside of India, like China or Europe and the Middle East, more than 80% of the utility projects are using bifacial. So I think this is already a proven technology in the market. So I think what we should do in India now is we hope more and more EPC and investor can start to step into this new technology. I don't think we have any technology concern anymore. The bifacial gain is already proven in all over the world. And I'm very happy to see the very big players in India already started to install bifacial modules. So I think this year will be, for India market, will be from monofacial to bifacial. So I think another popular topic recently is what's gonna happen next. So everyone is asking, so what you're gonna do next? To be honest, LONGi is technology driven, right? We are, to be honest, we are very reservative for the next step. Everyone is talking about N-type, right? And to be honest, for our wafer production, around 5% to 10% our wafer is N-type. So we are very familiar with this material. And we also have groups, R&D groups working on N-type. So both HJT and Topcon. I think that there will be only 2 choices for N-type. And I think we can see products from LONGi in the very near future. From the technology side, I think TOPCon is more close to the current cell process. I think this is a very easy step to work from monoPERC to TOPCon. You have to buy some extra equipment to do the production. And for module side, it will be very similar. And for HJT, I think in the future, maybe 2 years from here, HJT will be a very competitive product for the market like India, because we know that the HJT structure has very good temperature coefficient. So in the region, tropical region, with a very high temperature, so you can see very good energy gain in this region like India. But here's the problem. Definitely the N-type will have price gap between monoPERC to N-type. There will always be a price gap there. This is not from the initial cost. This is firstly from the wafer cost. So wafer, we have around at least 5%, 5% wafer cost there, and we have a process. The N-type process is much more complicated than the P-PERC. So we have then the production, we have the yield and the breakage rate, like everything. So for example, I think this will be a question to the developers, not to LONGi. I think, for example, if we have an N-type product, which can gain like 20 watts, but we definitely will have cost gap. So what's the cost the developer can accept to this 20 watts gain? I think this will be a challenging, not for the module maker, but it is challenging for the developers. So I think we can work with you to find a best balance for this cost gain. And last but not least, it's about the module and wafer size we are talking about these days. To be honest, to make the largest wafer, it's definitely not a hard work for LONGi. We can make hard bigger than bigger. This is easy for us. We have the best wafer technology, but why we choose M10? Why we choose 182? This is from this. We have our reason, right? So the bigger is not the best, but always we need to find a balance between the yield, between the production line. I think I introduced this quite a lot. I think this is the comprehensive conclusion from LONGi. So we will stick to this wafer size. And I also want to share to all the customers that we don't have any plan to have another size in the future.
Okay, thank you, Chris. I will go to the developers in the end. Let me bring Sai in here. Sai, so you heard Chris's comments. I think it will be really interesting if you can add some insights on how larger sizes are contributing to reduction in BOS costs, other project capex, etc. Also, I want to ask you, there is all these new technology changes going on, but we do hear from time to time that the newest technologies are not always reserved for the Indian market. Is there a lag between supply of the latest high technology products to the Indian market? Over to you. Sai, we can't hear you.
Yeah. Okay. Fine. Thanks, Vinay. Thanks, Rich India team. Thanks for inviting me for this particular panel discussion. Yes, specifically, if you just try to look at the technology landscape, which is what is there as Indian context. Definitely we are not every time a technology leader kind of thing, because we always try to follow the footprints of other regions where exactly the technology is being followed in. And we always try to look at the, we are not the front runner for going with any kind of litmus test on the new existing technologies like IBC or perovskite or any kind of tandem for that particular matter. Since we have even some kind of compliance issues, which is already in line for using them in utility scale segment kind of thing. But looking at the current perspective, so which particular technology is leading from front? If we just try to see that way back a decade ago, so it was the complete case of poly segment, wherein which 156.75 cell size and 123 those particular cell size and wafer sizes has ruled the market, and they have got their own time, to understand the market, and also they have optimized in that particular point of time to increase the wafer size and then getting into better efficiency models. Similarly, if we just try to look at this particular mono PERC technology, it just started way back. It just started 2 years before. So now we could see for at least for next 2 to 3 years the kind of growth optimization techniques, which is what is happening with mono-PERC technology within this particular P-type modules itself, which is why we could see the different wafer sizes are coming in, like starting with 182, 210. The reason is that if you just try to look at the wafer or the ingot processing itself, the channel of that particular chamber of that particular ingot itself is having up to 310 micron meters, which means we still can expect beyond 220, beyond 250 microns kind of thickness of these particular wafers, and closing to around like 300 kind of wafers also can be expected going forward in the next 2 to 3 years kind of time, because the ingot itself is having that particular capability. The ingot cylinder itself is having that capability. But not just limiting to that, too many optimizations are happening. Earlier, it used to be only with 5 bus bar, and now it has become 9 bus bar and now multi-bus bar. So HJT is one such kind of thing wherein which trying to eliminate that particular concept of having multi-bus bar and trying to create much more optimization in getting in reducing the I square R loss component within the cell itself. So these technology optimizations are happening, but looking at the Indian landscape for the next 2 years, if we just try to see and concentrate, the existing 182 wafer size and 210 wafer size are going to lead the transactions at least for next 2 years. And within this particular 182, 210, again, there are huge challenges as you are trying to showcase the kind of cost barrier, which is what is there. Yes, truly we can identify that. There are two different factors again within this particular aspect, if we just try to see. The major thing is that there is huge shortfall of material, not just specific to polysilicon, but also specific to glass. I'll try to showcase some kind of light, throw some kind of light specific to polysilicon. If we just try to see last year developments specific to the amount of metric tons which has been used for producing these particular cells, that has been limited to 570 metric tons. And considering the kind of 2021 trajectory, people were expecting that they should touch close to around like 720 metric tons. Even considering the average of 2.1 gram per watt peak for the module production or for the cell production, if you just try to consider that, it should touch close to around like 700, 720 kind of gigawatt capacity, 720 metric tons specific to 170 gigawatt kind of capacity. It's a kind of realistic figure, which is what is there. But looking at present scenario, for the values of polysilicon which is available in the market, it's not going to cross beyond 680 metric tons. The reason again is that for Q2 and Q3, it has to happen. But there are too many political constraints from the board of China, not allowing the people to manufacture this particular segment. So there is a kind of shortfall of polysilicon material itself. So whatever targets which have been put in forward to achieve 320 gigawatt capacity of cell manufacturing is or module manufacturing is not going to be achieved. The reason is that there is shortfall in polysilicon material. And the second barrier, what we could see is that with these kind of high efficiency technologies, people are expecting only beyond 530 watt peak module power class or 520 watt peak power class. And within this particular 520 or 530 or going beyond that, and this is happening only with 182 wafer size series and 210 wafer size series. If we just try to look at the glass manufacturing instrument, that is having the limitation of 2.4 meters as the length and 1.1 meter as the length, width barrier. So considering this particular aspect, comparing the same thing with 182 wafer size and 210 wafer size, only 72 cell is possible with 182 wafer size. And the moment if we try to increase the number of cells to 78 with 182 or 210 with 55 or 60 or 66, the instrument is not in a position to support that. If we want to do some kind of optimization on these particular glass instruments, again getting approvals for that particular thing and taking the first glass output from these particular machine, is not going to take not less than 2 to 3 quarters time. So considering these particular metrics, if you ask me, price reduction from these.
Sai, I think your line is not very good. We're not able to hear you. So maybe you just check on the line. I'll just go to Ivan in the meanwhile. Ivan, you've been on both sides of the fence, being a manufacturer earlier and now a deployer. Please try to make sense of these changes for us. And what does it mean for the Indian solar industry and for the developers? Also, what are you buying today? What are you deploying in the field as a developer yourself today?
Sure. Thanks, Vinay, and thanks the BTI team for inviting me, and thank you for giving the introduction. Right. So I think we are right now in a, I would say in India, as Chris pointed out, we are in the transition phase. Okay. Till last year, most of the installations that were happening were with multi. And today we are getting into mono territory. Okay, and this is one of the big shifts in module technology, because I know this because I have been both, as you said, I mean, putting on the manufacturer's hat as well as now I'm having the developer's hat on. So fundamentally, this shift is inevitable, and in fact, we were predicting this 2 years back. But now it's happening, and this is really happening for the good. Now there are I mean, few reasons why this. I mean, for India, it is inevitable to make this shift. One of the first reasons is the availability of supply chain. And India, we are dependent mostly on Chinese supply chain for modules, and the entire Chinese industry, PV manufacturing industry, has moved to monoPERC in the last 2 years. The transition has been absolutely complete. From nobody probably makes multi anymore. So that's one. So dependency on that, and then with coming in of bifacial modules, trackers plus bifacial, etc. And with the higher power class of modules, suddenly monoPERC with the configurations that with these latest configurations is making a lot of sense, and in terms of LCOE as compared to multi. So if you see the multi visibility of multi getting into bigger wafers is not there. However, there is monoPERC, which is there's a visibility of getting into 166, 182, and 210, which is already happening. So the power class improvement on top of efficiency improvement, all these things are driving the market towards adoption of these new technologies. Now that is as far as the the end user or the developer is concerned. Now let me take a step back and talk about what is happening on the manufacturing side, because that is also closely linked with the changes that are happening in the Indian manufacturing sector also, because there's a lot of more people who are getting into manufacturing, more new players are coming into manufacturing. So obviously, the 4 or 5 new things that are happening, wafer sizes are changing, bigger and thinner mono wafers are coming up. There are talks of monopar getting into tandem, monopar getting into TOPCon and then getting into tandem solar cells, which is also looks like we are 4 or 5 years away from commercialization of tandem technologies, which is again takes the game away to to very high efficiencies. Bifaciality and high density modules, those things are also have come in, and therefore there's a lot of focus on developing those technologies as a manufacturer, and bringing in the value to the end user. The module power and price. So power has increased, price has come down. So everything makes sense, right? For developers or for for the market. And then another good thing that has happened is there's a lot of data analytics and availability of field data and data analytics which have come in, which helps us to analyze performance of modules in a very short period of time. Like for example, if I were to adopt a new technology with which is fairly new, maybe in India it is coming in for the first time. Let's say multi-bus bar with different ribbon connection technology with high efficiency monoPERC 22.8, 22.9%, and then with with a different backsheet material or a different glass. So a host of new technologies are coming in. Now to analyze the data from this kind of, so I would straight away, first of all, I wouldn't go for a 100 megawatt deployment at the start. So I'll try to deploy a pilot, couple of megawatts, 2-3 megawatts, but then getting the data on the degradation of these modules or performance of these modules over a shorter period of time is actually very key. And now with a host of data analytics, machine learning concepts that have been brought into both downstream and upstream sectors, it's very easy to sort of get very early pointers to which technology is going to move ahead. And such things have come in just very newly in the market. And there's a lot of, mobile testing that is being done. There's a lot of on-site characterization that can be done, which was not possible 5 years back or 3 years back. So I think all of these taken together has moved the game away towards making high efficiency, lower cost of ownership, lower LCOE, and higher reliability has become really the key points in this game.
Yeah, thank you, Evan. I think that sounds like music to many ears. Nikhil, I'll come to you now. All this is very good, but there are a whole host of bankability and certification issues in the Indian market. How are you dealing with those? Is BIS testing infrastructure keeping pace? Are you able to buy and use the latest modules? And then, of course, there is the ALMM, etc., etc. Sorry.
Thanks, Vinay. So, as you said rightly, to Mahindra, we always wanted to try out new technologies. At the same time, as right now we have already in our projects, we have already using models of around 440 watt peak models, which is using up M4 or M6 solar cells, wafer side. At the same time, still what we are seeing, world has already moving towards 182 as a mass scale, and even 210, and so availability is there. But still, for as far as India is concerned, still you will not have a multiple choice with you and as a manufacturer for at least when we say 182 wafer size modules or 210 per set module, because still the certification BIS certification is in process. And the time what we have observed is there is around a 6-month time lag between the IEC certification of the manufacturers to a BIS certification, and getting you get it tested and then submit the report and get a certification. It's around 6 months. So we are seeing at least a 6-month lag between the when LONGi is ready worldwide with the certification for their modules, and when we talk about for India specific markets, it's a 6 to 7 months lag is there. So in a way, that lag is good also. At least we have some amount of data of the modules which is being installed worldwide. Yes, availability of the data is really challenging, but you get to get some feeling and sense how the overall market for those products, and even for LONGi or Jinko, for them also it's become good. Okay, when they're coming to India market, they have some backup data also with them. So that's how the things on certification. Yes, ALM is still, I think, Jinko and LONGi, and still it's not, it's a mystery for us also, because we are also not able to figure out when to take this into account when we are buying, when for which quarter or which year this is going to get implemented. So that is something is still, I think, revolving around and going back to the same tables once again. And still, I think it will take some time. As far as technology is concerned, yes, as you said rightly, bifacial is something which definitely is going to be one of the key market segment percentage-wise. It will be definitely for this year maybe, and also for next year definitely it's going to be 30-40% market share for new installation is going to take a bifacial. Because we are also, as Ivan also said, the pilot is the best way to learn and understand the technology, and the way we have also done in our Riva plant that we have installed also bifacial modules, and they are also we are evaluating both P-PERC and PERT from one of the suppliers, and we are seeing the performance of P-PERC is much better than when we are comparing with NPERC. So that is something which we are on real-time basis. We have the data, so and that's how we get more confidence on the technology. And definitely wafer size wise, yes, there are a lot of confusion. 2 years earlier we have only one set of module, so it's much easier. You only have to select the manufacturer to whom you want to go. But now you have not only manufacturer, you have to select the cell technology, you have to select the even interconnect region. We have 2 manufacturers and both have the 2 different interconnection technologies. So cell to cell interconnection of Jinko is totally different. The cell to cell interconnection of LONGi. So now you have another variable coming to picture. So the even one uses round even, one uses triangular. So their numbers are variation which is there small variation within the modules, for which wattage may be same, but the impact upon the overall generation, the impact like low radiance performance, the impact on the IEM losses. So those numbers will get changed with these minor changes, and that is something is for a developer. It's very important that how much and how you can extract from whatever you have in the field, and what are those things which is going to give you additional output and the longer term. That is something we do at on a regular basis.
Okay.
Thanks.
So now we'll throw the floor open to everybody, and I want to really start by asking everybody a couple of questions about the bifacial modules. I think everybody outside the solar industry is very intrigued how the bifacial modules work and are they really the future. So whoever I talk to says bifacial modules are very good, so much power, extra power output, etc. So the question really is, when, if that is so, what is the delay in 100% adoption of bifacial modules? By what time can we expect 100% adoption of bifacial modules? That is question number 1. And question number 2 is, what is the extra power output can we expect? And I think this is a very, very relevant question, because in the Indian context, when there are so many auctions taking place, I hear people are making different kind of assumptions. Somebody is assuming 20%, somebody is using 25 or 29% extra output gain. So what kind of output gains can be realistically expected with trackers in the Indian market? So Chris, over to you, but then I will expect everybody else to contribute their viewpoints.
Talking about the bifacial technology, I think we released our first bifacial products 4 years ago, 2017. And I think so far we delivered more than 10 gigawatts to the global market. So as I just mentioned, this is a proven technology. So what I want to emphasize right here right now is about the reliability. Actually, the bifacial is, as we all know, because of the cost, the bifacial modules will be a little expensive than the monofacial ones. This is the cost gap is from the material itself and also from the production, because the yield will be a little lower. So there will be a little price gap there. But what we offered for this product is we have a 30-year lifetime. And during the 30 years lifetime, the energy degradation, because of this good glass-to-glass structure, which help us to reduce the power loss. So we have extra 5 years lifetime, and we have around I think there will be around 5% less yield power loss. So this, I think initially the investment definitely will be a little higher than the monofacial ones, but we can see in the future, you can see very soon the energy gain will compensate the initial cost. So I think another point is we think this transition is happening in India, but it will not replace all the monofacial. I mean, even for the utility, normally we will not recommend our customer to shift all this project to bifacial, because we have to evaluate your land, the climate, the environment, everything. Then we will, based on this, we will suggest you to go to bifacial or monofacial. And I think bifacial, monofacial, and it's also for rooftop, for residential. It will always be there. So it will not change to 100% bifacial.
Okay, thank you, Chris. Anybody else wants to respond to that? Sai, you want to respond to that? Sai, I think you're muted. We cannot hear you, sir.
Yeah. Now I got unmuted. Yeah. So fine. So specific to the question of bifacial technology, yes, that it's again this particular bifacial technology completely is getting accepted widely everywhere. The major point from the perspective of any developer is that it makes more sense only if that particular LCOE calculation makes feasible for him to consider this kind of technology. I'm comparing the LCOE pattern with monofacial modules. These kind of bifacial modules definitely helps like anything specific to LCOE part, and not just limiting to that. If we just try to look at which particular locations or which particular textures of the soil generally makes these kind of bifacial installations favor in India, and in that particular context, if we just try to see in most of the rooftop installations anyway, they all will be having low soil moisture content, which is always good to go with these kind of bifacial technologies. The reason is that reflective sensitivities will perform better for these kind of rooftop installations. And looking at these kind of utility scale segments, most of these particular utility scale segment projects also comes in barren land kind of areas, or for the regions or the locations which is having rocky surface. So for all these kind of locations, if we just try to see, the soil moisture content is very less, which means the thermal coefficients of that particular location is very high, and reflective sensitivities of these particular soils is going to be too high. So that can determine.
So sorry, I want to interject here. What kind of power output gain can you expect using bifacial and tracker technologies in India?
Yes, I'm coming to that particular point. If we assume assuming for Indian kind of zone, tropical climatic zone, if the albedo is ranging in between 20 to 30% kind of zone, we definitely can expect a minimum gain of around like 7% on a fixed tilt kind of system. If you are trying to go with trackers, 14% to 15% gain can be expected. So, but yes, we even are hearing about 22%. But for that's completely for locations if you're having albedo beyond 80-85% kind of zones, or on the land surface itself, if you are trying to put some kind of reflectors and trying to increase the albedo factor. So that is possible up to 20-22% as well, which is what we have noticed in Peru kind of locations. But for Indian context, if we just try to see with tracker kind of optimized technique with bifacial, 14% is achievable.
Okay. Ivan, Nikhil, your viewpoints?
Yeah, Vinay, just a quick point here. You see, you need to understand the history of how bifacial came about first. 3 to 4 years back, when we talked about bifacial, we only talked about N-type wafers or N-type cells, okay, PERT cells, which were inherently capable of getting a bifaciality factor of over 85 to 90%, if produced correctly. And therefore, the energy gain there was much higher. And also, the process was more expensive. It involved boron diffusion, etc. So therefore, it was more expensive, and it was not favored by the developers or by the users, especially for utility scale, where the real benefit of bifacial is in utility scale solar. But then 2-3 years back, what happened was when the P-PERC process was adopted or modified to make P-type bifacial. While you make a P-type bifacial, you actually, the critical thing that is, what is the bifaciality factor that you get? Okay, for what is the bifaciality factor, which is the ratio of the rear side power by the front side power. Now, you can get high energy gain if you get bifaciality factors. I mean, the current bifaciality factor is somewhere around 74-75% for most of the manufacturers. But then you can actually tweak the bifaciality factor higher, but you have to sacrifice the front side efficiency. In the process itself, you can do that tweaking. You sacrifice the front side efficiency or front side power and improve the bifaciality factor. So that's the reason you get areas where, in India, where you can get anywhere between 15 to 20% kind of numbers in time, depending on the type of albedo. That's what Sai said just now, but also depending what kind of modules you are using. Now, suppose in that same geography, you are using a N-type wafer module or a heterojunction module, you will get much higher energy gain than 20%, maybe 25%. But these things have not been deployed, or these new technologies have not been deployed in all types of terrain, all types of geography in India, because India has 5 to 6 distinct climate zones and distinct terrain features with different albedos. So sufficient data is not there to see how P-type bifacial versus N-type bifacial versus heterojunction, what are the gains with these technologies in all these areas. So it's really really a very rhetorical question to ask that what should be the bifacial gain that we should achieve. There is no clear-cut answer.
Okay, I think I understand that. Nikhil, you said you've been running some pilots at your end.
Yeah, so as and running the pilots just definitely give us more data. And as Sai said, something around 7% for albedo of around 20% strata, which we have at our site, and we are able to get something around the fixed plant. We are getting already 1 year has happened, so and we are getting around 7% by fiscal gain, around 7%. So it's depend upon month to month. So in the winter month, bifacial gain percentage number is higher, but in energy terms is lower. But overall, in summer terms, you have percentage gain is lower. It's around 7% is what we are getting in the case of fixed tilt. And that's where the point is that this is around with the strata having around 20% albedo. And that's where in the case of Rajasthan, which we are moving, one thing which is very important, this number is for a minimum height of 1 meter. And if you go for a minimum height of same as fixed standard monofacial, something around 0.4 or 0.5, this number is has gone to something around 3.5 only. So then this number of whatever size, same sample I am saying, this depend upon the multiple things. What is the ground coverage ratio? What is the height, minimum height? It's not only the okay, I have put a bifacial on a fixed structure, and if I put it on the same monofacial, I am getting something around 3 and 3.5%. So it's merely it even not able to meet the cost difference also.
Sure.
So
No, understood.
Take care.
Sorry, Nikhil. I think that's very interesting. I understand the point. You know, one thing we have always talked about in India is that India is an extremely price-sensitive market. We want the cheapest, and because of that, we have always been late in switching to new technologies, and we've been kind of missing out on high-efficiency modules, etc., etc. Is that I get the sense that that is beginning to change? I mean, is that right, or is that not yet the case? Anybody who wants to answer this?
That is changing. I think I will definitely say it's changing. It's not the same case, and it's not that it's by habit we are changing it. We are also being forced to change it. Yes. As Ivan said in the beginning, also the supply chain is also one of the major concerns. To get a module, the volume which we are making a project right now. Now the project size has moved. A minimum project size, if you talk, is 250 megawatt AC, 300, 400 megawatt AC. For that project size, if you want to have a reliable supply chain, to get that, if you still want to go with poly, then you have to go for multiple manufacturers. And then you have all the, even you fix the bomb at each and every place as same, you will not get the same quality, and it's become very challenging for you. So that is something also is a concern.
Sorry, we had a poll question coming up, so but we can keep talking in the meanwhile. Sorry, Ivan, go ahead.
Yeah, so I think one major reason why the adoption of higher, more advanced technologies has been much more prevalent right now is because, you know, the gap between one is the Chinese industry has got consolidated. Instead of having 20 manufacturers, you have maybe 5 or 6 large size and large manufacturers. With the always the highest production efficiencies, etc. And for them, like LONGi or Jinko, making a low efficiency product on the same line doesn't make sense anymore. So 100% of production is always has moved to higher efficiency. Yeah. That is the supply chain that we are dependent on. So it's just that the certification, and this is something that that's always been the case of India, where first BIS and then ALMM. These are the you know, non-technical reasons why we are late in adopting technology. For example, I mean, if I have to adopt a pilot today or deploy a pilot, why do I need a BIS certification for certified modules for that? I'm not deploying a 100 megawatt project where so I should not. I should be allowed to import modules, get deploy them in a pilot, high efficiency module, deploy them in a pilot, study it for 6 months. By the time the BIS is ready, I am ready to deploy it in a 100 megawatt or a 200 megawatt project. I think that is something that we need to do from the industry standpoint, from the government side also. I think the effort needs to be put in that direction. But the gap has definitely narrowed. I mean, it's maximum 2 quarters, and the difference is only because we have a delay in terms of certification and other things for getting the best, highest efficiency modules in our country.
Okay, I will just take a few questions from the attendees, and I think one of the frequent questions or question which has been asked many times is, what is the impact in terms of the BOS and the design of projects in India? Are there any kind of local supplier side ecosystem kind of issues which are kind of delaying the installation of these new modules? In terms of BOS design and installation of these projects. Open to Nikhil, Ivan, any of you want to take it?
I can definitely have my input that at least at Mahindra right now we are already installing this 450 megawatt, 450 watt peak modules, and we are already in discussion with our partners for modules of 535 watt. So we don't see any local specific issues for deploying this. As I said, BIS is one of the point where our partners are still awaiting for certificate from the BIS, or they have submitted the reports. That is the only delay which we see for adopting these modules for deployment in our project. So to me, other than certification, I don't see a very specific issues in deployment of, because already our team is handling glass modules already. Modules of more than 27, 28 kg is already being handled. So on that front also it's not a big issue. So overall, MMS design and everything, I think India, we are capable, and we are doing it. We are manufacturing in India a good and quality structure. So I don't see tracker. Just we have limited capabilities in India. Even at Mahindra, we are working on trackers. We have own learning curve is there, and still we are going through that. But definitely, just tracker is the area where, as overall India wise we are lagging. Still it will take some time to have our own setup manufacturing of trackers in India. Otherwise, I don't see any specific challenge to adopt.
Okay, thank you, Nikhil. One of the other questions, surprise, is about prices. What is the pricing outlook for, let's say, monofacial modules for 2021? Sai, do you want to start with that?
Yeah, that's fine, Vinay. So the point is that if you specifically ask me the kind of pricing, which is what is there for Q1 of 2021, and if you just try to compare for Q2, Q3, Q4, I can't see any kind of variation which is going to happen within a cent gap, which is what we could realize. The delta which is going to be maintained between Q1 pricing and Q4 pricing is not going to be more than 0.8 cent is what we could see. That's also just happening just because of the earlier explained reason. The material shortage is huge, and we find much more challenging factor basically on the raw material aspect, specifically to polysilicon and the glass. So these two are the major variants which is throwing challenge to every module manufacturer in China. So hopefully even LONGi also endorse the same thing, because we even are following the same wafer size of 182 mm wafer size for these kind of high efficiency technology modules. And going forward, yes, definitely for 2022, we can expect some kind of betterment in the existing price trajectory, but not immediately for 2021.
Okay, I will ask the same question of Chris, and I would just add to that that most Indian developers, as far as we know, are factoring in big price declines in the coming 1 or 2 years. So, Chris, your comments.
Yeah, I think just like Sai just introduced, the biggest pressure is from the price of poly and glass. I think in the last quarter, the glass price, I think, already doubled. And because of the pollution control, the China glass maker cannot expand their production line. So I think the glass company already, including all the module makers, are already submit a letter to the government. So I think from now on we can see a new glass capacity built. But I think the glass when they start to invest to production, it will need around 1 year. And we also see, because the economy recovery in China is very strong, So we also the infrastructure demand of glass is also huge. So I think in this year the glass shortage will continue. And for poly, I think, as I just know that the poly of this quarter is already sold out. So, I think this is really tough, not only for LONGi and for all the PV industry, but I think this will continue for 1 year at least. So from our side, what we can do is, for example, for poly, we have a very close partner with our poly suppliers. We have a very close, even to co-investment with our poly supplier to secure the poly supply. So at least we can have a very steady supply from them. Maybe the price will go a little higher, but we can get a very steady supply chain there. And for glass, I think we already signed a very long contract with them. So I think at this time, the financial health is a key point to module suppliers, because I think for LONGi, the financial health is also one of our biggest points in the industry. So I think we have a very strong financial power to get the steady supply from the glass. Yeah.
Okay, thank you, Chris. We are running out of time now, so we'd like to conclude the session now. Thank you very much to all the panelists for their very valuable insights. I think for me, the key takeaway as a research and consulting company is that for a start, I think these changes, they demonstrate the uniqueness of solar technology. I think solar is already the cheapest and is kind of becoming the most reliable source of power. It's been called the king of power production for good reason. I think it is very refreshing to see all these new changes being introduced worldwide and those being adopted in India with a very shortening kind of timeline as well. So on that note, we like to close the session. I will just pass over to my colleague Sangeeta for final few remarks. Sangeeta, over to you.
Thank you, Vinay. Thank you to all the panelists for being a part of today's webinar and sharing your valuable insights with us. I would like to once again thank LONGi for their support. We will be sharing the recording of today's session to your registered email account, and it will also be available on our website. Our next webinar is titled Getting to Solar Tariffs of INR 2 rupees per unit, and it's scheduled on the 25th of February. Until then, it's bye from all of us.
Thank you.
Thank you very much.